Have you ever seen the real Jupiter? Not the illustrations in textbooks, not the colorful ball in cartoons, but Jupiter itself as captured by probes. When these true photographs were released, countless people cried out, "This can't be real." Those riotous swirls of color, the vast storms that ceaselessly spin, every frame looks too beautiful to be true. Because these images make everything startlingly clear, they aren't just simple still photos. They are living, breathing evidence, frame by frame, recording motion and structure. Some say they look like CGI from a sci-fi movie. Others even doubt them, insisting they look exactly like AI-generated pictures. What is it, exactly, that makes hundreds of millions find them unbelievable? The inky, surging storm seas of cloud, or the giant red spot that resembles a monstrous eyeball? In this video, we'll uncover Jupiter's true face and why this planet can make humans doubt their own eyes. Deep within those roiling clouds, what other secrets is Jupiter hiding? Jupiter used to be nothing more than a blurry splash of colors in science books, a mysterious world forever out of reach. But that is changing fast. We are now witnessing the clearest real images of Jupiter in human history. Some shots were snapped from the Juno probe's close passes along its elliptical orbit. Others come from the Webb and Hubble Space Telescopes. Working in concert, infrared, ultraviolet, and visible light, these instruments observe the gas giant in a full multi-band sweep. Unexpectedly, the most stunning images were processed and stitched together by ordinary people using NASA's publicly released raw data. They turned science into art, data into visual miracles, planetary artworks in their own right. And yet, strangely, the closer we zoom in and the clearer the images become, the more the mysteries multiply. Jupiter's cloudscapes change in surprising ways. The great red spot is shrinking at an astonishing rate, and some enormous storms form and dissipate within mere days. Deeper down, the atmosphere seems to conceal an eerie hidden core unlike anything seen on any other planet. So these are not just pretty pictures. They're reshaping how we understand planets, storms, moons, and even the early history of the entire solar system. Once a tangle of rusty bands and blurred stripes, Jupiter now feels like a cosmic canvas. Deep blues, gentle pinks, icy whites, and storm-gray streaks interwoven. Some patterns look like natural marble. Others recall waves frozen mid-crest. And all of it is real, raw imagery from the solar system. Most of these jaw-dropping pictures come from Juno cam aboard the Juno spacecraft. At first, that camera was only meant to take attractive photos for public outreach, not to shoulder hardcore science. But then artists, scientists, and programmers worldwide jumped in, downloading the unprocessed data. Using their skills, they transformed those images into artworks that look interstellar. In one photo, a colossal cyclone appears like a supercharged hurricane, roughly Earth-sized. In another, a cluster of smaller storms spirals like flower petals. Some cloud patterns are so finely detailed, you can see shadows cast between different atmospheric layers. You can even perceive depth on this almost entirely gaseous world. No accident, no lucky snapshot. Juno has been orbiting Jupiter since 2016. Because its orbit is continuously adjusted, each perijove pass brings it closer, yielding higher resolution, richer detail, and more favorable lighting. Sometimes you can even see sunlight skimming the edges of storms like a sunset on Earth. Along the way, Juno has captured phenomena scientists never anticipated: mysterious bright spots, new storm systems, polar tornado chains, and high-altitude hazes that change color as the light shifts. This is no longer mere photography. It's like meeting Jupiter's personality for the first time. A lively, kinetic, ever-changing world more complex than we imagined. As mesmerizing as the high-altitude views are, things turn downright uncanny when Juno dives low, low enough to make out every wrinkle on the face of Jupiter's storms. Juno's recent passes weren't lucky flybys. They were meticulously planned deep dives. Each trajectory is calculated to skim just a few thousand kilometers above the cloud tops. You can think of it as grazing the surface of a world made of storms. What Juno has seen up close reads like science fiction. Take the famous Great Red Spot, a storm that has raged for at least 300 years, perhaps far longer. For the first time, high-resolution, true color images reveal its structure and detail. The Great Red Spot isn't just a storm, it's a nested monster, layers within layers, as if anchored by some force beneath the clouds. The latest images show its architecture more clearly than ever, even capturing small vortices being swallowed whole by the giant storm. The spot looks like a colossal eye, slowly blinking as surrounding cloud bands are silently drawn into that red abyss. Stranger still, the Great Red Spot is shrinking. That part isn't news, but now scientists can precisely track the pace of change. And while it's narrowing horizontally, it's growing taller vertically. This upward swelling was never predicted. The mechanism behind it remains a mystery. Fly over Jupiter's North Pole and you'll see something beyond imagination. The neat belt and zone layout breaks down into geometric formations, hexagons, heptagons, even octagons. Each storm spins around a central airflow, evenly spaced like petals around a pistil. These circumpolar cyclones are not stationary. They're gigantic hurricanes that endure for years while somehow maintaining formation. Between them lie deep blue gaps that seem calm but may conceal faster, denser undercurrents. As of now, nothing else in the solar system shows anything like this. On a recent pass, Juno even caught fleeting traces of high-altitude, high-speed jets, never detected on earlier missions, scoring clear streaks across the cloud bands. They reveal that Jupiter's atmospheric layering is far more complex than we currently understand. Ironically, many of the most dramatic photos weren't even part of the mission's original goals. Juno wasn't built as a long-term imaging platform, and no one expected it to last this long. But it has, and it's still flying. With every orbit, it brings back sharper images and more astonishing data. Bit by bit, Jupiter is lifting the veil it has worn for millennia. And just when you think Jupiter can't get any stranger, its moon Io barges in and steals the show. Io is nothing like our moon. It's a wildly active world. It hosts thousands of volcanoes, some erupting without pause. For the first time in over 20 years, Juno has let us see it up close again. In several recent flybys, Juno tweaked its trajectory to sweep past Io and capture jaw-dropping scenes. Eruption plumes jetting straight into space, lava lakes glowing on the surface, vast regions scarred black by past outbursts, like a planetary fireworks display, only fiercer and never-ending. In the sharpest image, you can even see a volcanic plume rising over Io's horizon, shooting hundreds of kilometers high. All this on a moon about the size of ours. Io's madness is fueled by Jupiter's gravity. Because it orbits so close, Jupiter's pull constantly stretches and squeezes Io's crust like kneading dough. That relentless flexing heats the interior, melts rock, and powers continuous volcanism. Io is, in fact, the most volcanically active body in the solar system. And the value of Juno's images goes far beyond seeing eruptions. They reveal how Io's surface changes over time. Scientists are comparing data between flybys to track new lava flows, the changing shapes of calderas, and differences in thermal emission from hot spots. Some areas that were calm and flat months ago are now draped in fresh volcanic deposits. We are witnessing, in real time, the geologic life of a world that never rests. And this isn't just a surface spectacle. The sulfur and plasma that eruptions spew into space feed Jupiter's radiation belts. In other words, this tiny moon is nourishing the most powerful planetary magnetosphere in the solar system. More astonishing still, the process isn't one way. Juno's instruments indicate that magnetic disturbances and particle flows near Io seem to vary with the intensity of its eruptions. That suggests a strange, violent feedback loop between Jupiter and Io. Every eruption injects energy into space, and every orbit twists the moon even more. These images aren't merely cool pictures, they're the first clear evidence of a world tearing itself from within. Think Juno is the only one delivering close-ups of Jupiter? It isn't working alone. Thousands of kilometers away, the two most powerful space telescopes ever built, Hubble and Webb, are quietly watching from another vantage. And what they see is equally mind-bending. The James Webb Space Telescope trained its infrared sensors on Jupiter and captured a spectacle never seen before: a high-speed jet racing across the equator at more than 500 kilometers per hour. Hovering above the main cloud decks, it's so fast that even in long exposures it shows up only as a smudged streak, like a hidden dark river at the top of the atmosphere, invisible in visible light. Meanwhile, Webb has detected anomalous heat signatures deeper within Jupiter. In some regions, heat seems to be rising from beneath massive storms. That implies far more vigorous and complex vertical activity inside Jupiter than we previously imagined. At the poles, Webb's infrared imaging reveals gigantic auroral rings, akin to Earth's northern lights, but on a much grander, more energetic scale, powered by Jupiter's mighty magnetic field. Hubble, though long-serving, still contributes priceless visible and ultraviolet band data. For years, it has monitored storm evolution, cloud migration, and shifting colors. Compared with Juno's close-range dives, Hubble offers the planetary big picture from on high. When data from Juno, Webb, and Hubble are combined, a fuller, more three-dimensional portrait of Jupiter emerges. Storms that seem placid in Hubble's global views are, at Juno's range, churning like whirlpools inside. Regions of thermal anomaly that Webb spots later show, in Juno's flybys, newborn cloud towers, vortices, or clumps of turbulence. These coordinated observations weren't originally planned, but they've opened a new window, forcing scientists to rethink Jupiter's atmospheric architecture and its effects on the surrounding space environment. We are gradually piecing together the whole of Jupiter, from razor-edged cloud textures and boiling deep heat flows to icy cold, high-altitude jet systems. Jupiter is no longer a fuzzy gas ball, but a stratified, vibrant, mercurial world. And this is only the beginning. 2 new missions to Jupiter are already en route. They won't just take pictures, they'll probe the oceanic worlds of Jupiter's moons and the secrets buried beneath their ice. As you watch this video, 2 spacecraft are racing toward Jupiter, not merely to observe the gas giant, but to delve into its satellite system, hunt for subsurface oceans, and scan for signs of life. The first is JUICE, the Jupiter Icy Moons Explorer, launched by the European Space Agency in 2023. It won't arrive until 2031, but once it does, it will focus on Jupiter's most intriguing moons, Ganymede, Callisto, and Europa. Scientists widely believe these aren't just cold ice balls. Each likely harbors an underground ocean, liquid water hidden beneath kilometers of ice. JUICE carries radar, spectrometers, altimeters, and magnetometers to probe the depth and salinity of those oceans, and even whether they might host signs of life. It will also become the first spacecraft in history to orbit a moon other than our own. Its target is Ganymede, the largest moon in the solar system, bigger than Mercury, and the only moon known to have its own magnetic field. What secrets lie within Ganymede's interior, and why does it possess a magnetosphere? What lurks beneath that thick shell of ice? Perhaps only JUICE's arrival will let us begin to answer. The other mission is NASA's Europa clipper, aimed at the moon most celebrated as a potential cradle for alien life, Europa. Launched in October 2024, It is expected to reach the Jovian system in 2030. Unlike JUICE, Europa Clipper won't go into orbit around Europa. It will conduct dozens of close flybys. Using ice-penetrating radar, it will scan the structure beneath the crust and analyze the chemistry of Europa's thin atmosphere. With luck, it may even detect plumes erupting from fissures in the ice. Europa is special not just because it has water, but because its water may be active. Jupiter's powerful gravity constantly kneads the Moon, generating friction and heat, potentially creating deep-sea hydrothermal environments like those on Earth, which could be hospitable to life. Europa Clipper's goal is to get as close as possible, without landing, to conduct the most detailed remote observations yet. These missions matter because they build on and extend today's observations. Juno gives us intimate close-ups. Webb and Hubble supply the wide-angle cosmic view. JUICE and Europa Clipper will probe the inner workings of the Jovian system, secrets hidden beneath ice and cloud. Frozen oceans, chemistry, potential energy sources, and even the possibility of life. Once both craft arrive, we'll have an unprecedented multi-platform synchronized campaign. The Jovian system is poised to become the most deeply and comprehensively studied region in the solar system. Every image, every flyby, every radar ping is another rung on humanity's ladder to understanding the cosmos. This isn't merely the exploration of one planet. It's the unveiling of a miniature solar system, circling a giant that may conceal clues to life beyond our imagination. These breathtaking images may look like pure eye candy, but they're far more than that. Every eddy, every hue, every bizarre storm is a clue. By analyzing them, scientists are uncovering secrets no textbook ever touched. Let's start with Jupiter's atmosphere. People once thought its weather was confined to the surface. But Juno's microwave radiometer and high-definition imagery show that many storms are three-dimensional, plunging hundreds of kilometers into the clouds and carrying heat and chemicals deep inside. This upends our models of gas giants. Jupiter's storms aren't mere cloud-top cyclones. They're vertical weather systems with true dynamical depth, now the Great Red Spot. To the eye, it's a giant red oval, but long-term tracking by Hubble, Juno, and Webb shows it shrinking even as it grows taller, evidence that its energy budget is changing. Perhaps energy is being shunted deeper down or spreading through the atmosphere in new ways. As for the colors, they trace chemistry. Some regions are rich in ammonia, others in sulfur or phosphine. By tracking color changes, scientists can infer jet streams and pathways of chemical transport. Next, the magnetosphere. Jupiter has the strongest planetary magnetic field in the solar system, about 20 times Earth's. Data from Juno, along with the auroral shapes imaged by Hubble and Webb, reveal that this field is asymmetric, tilted, twisted, with field lines plunging into the planet. That hints at something unusual inside Jupiter. Perhaps an unexpected core configuration, or liquid metallic hydrogen behaving in ways we don't yet understand. Finally, Io's eruptions aren't just geologic fireworks. They're reshaping the space environment around Jupiter. Each outburst releases sulfur and sodium into space, replenishing the radiation belts and forming a torus of plasma encircling the planet. In some Juno images, you can even faintly make out these glowing ring-like traces. Webb has also identified those blistering high-altitude jets, moving incredibly fast and possibly linked to deeper atmospheric layers. In other words, we may have uncovered a brand-new atmospheric system, floating above the familiar cloud decks and never before recorded. All these findings are assembling a Jupiter that's richer and more elaborate than we ever imagined. Not a simple sphere of gas, but a layered, interactive planetary system. Storms rise and collapse in cycles, gases migrate between jets and bands, the magnetic field pulses through asymmetries and complex dynamics. It's like a living machine, running on physics we're only beginning to decode. These images aren't just gorgeous stills. They're dynamic, deep, real-time evidence of an alien world that still guards countless secrets. Thanks for watching this episode. See you next time.